So this is session number 8, where we're going to talk about datums. Uh, what are datums actually? So normally during machining, inspection, and assembly, parts are positioned on datums, and datums are just reference frames that are used as a basis for calculating or measurements. These are just reference frames from which we start measuring locations, for example, of other parts. Datums are features such as points, axes, or planes uh, on the object, and these features are used as reference surfaces, reference point or reference axis or reference plane, from which other measurements can be made. So the reference frames or datums are used in designing, are used in tooling, manufacturing, inspection, assembly, and all those processes. So this drawings here shows you the datums, two datums, datum A, which is called the primary datum, which is the bottom surface here, is defined as the datum A. And then datum B is this vertical surface here. So datum A is the primary surface, datum B is the secondary datum. Datum A is the primary datum, and datum B is the secondary datum. The dimensions on these drawings do not comply with BS8888. The only difference is that we have to have a continuous dimension line here, and these dimensions should be written outside the line. The same for this one and this one. This is the only difference. But here, see, for example, this dimension is boxed here, this dimension is boxed, this angle is boxed. This just means that the tolerances for these dimensions are going to be using the GD and T. For example, we have here, this dimension is 1, but this surface here has some sort of like feature control frame here that says this surface should be parallel to relative to A, should be parallel to surface A, which is datum A, and the parallelism of this surface here should be within 0.005. What do I mean by that? It means that this is our reference frame, this is our datum from which we can measure the this dimension, which is 1. But this surface here should be parallel to this surface within this tolerance. So if we draw like two lines, one at the top and one at the bottom, and the difference between these two lines is 0.005. So this line here, this real line, this solid line, can take any angle, could be like a little bit going upwards, a little bit going downwards, but the most important thing that it should always lie within these two lines, these two boundaries that we have defined to be accepted. The same for the angle, it is boxed here, meaning that the tolerances are defined by GD and T. Then we have an angle of 20 here and says the angle of this line or this surface here should be within 0.005 with respect to or relative to B. So this angle is measured from B. So this is the datum for the angle. So we should measure the angle starting from B here, surface B, and then we have 20 degrees. But this 20 degrees is not like is without tolerances. So the tolerances are defined here. So if you just imagine that you draw two lines here parallel to this line, one below, one above, and then the distance between them is 0.005. So the real line here, this line here could be could take angle little bit down or little bit above, but the most important thing that it should lie within between these two lines that we have drawn with a distance of 0.005 in between. So the datums actually are quite important because features are identified with respect to a datum, as you've seen on the previous slide. we say that this surface is parallel to the datum, or this angle is measured relative to the datum. So the datum is our reference surface from which we start like measuring other dimensions or other features. Always we start by letter A as the primary datum, then B, C. The information of the datum and the geometrical dimensioning and tolerances are just located within what's called the feature control frame. As you've seen, this is the symbol for location. This is the tolerance. This is the maximum material condition, and this is the datum. So datums on a drawing of a part are represented using this symbol. So on the surface, on the part itself, we should define at least 3 datums, and then these datums on a part we are going to define some datums, and those datums we use this symbol for the datums. We have like a triangle here, and then line, and then a box, and then within this box we write either it is datum A, B, or C. So datums can be placed on some features. So for example here, see, so we have datum A, we have datum B with this symbol. So the datums here can be attached to an outline surface, or could be attached to an extension line, for example. It also could be attached to a tolerance frame. So here is the feature control frame, and the datum here is attached to this feature control frame, and the feature control frame itself is attached to this surface. So it means that this surface is used as the datum C. Here, this surface here, top surface, is used as datum A, and this surface is used as datum B. So the datum itself could be attached directly to the surface or extension line, or could be attached to this feature control frame, where the feature control frame itself is attached to another thing like this surface, or this top outline here, or this extension line. It could be attached to a visible surface straight away, like saying that this is like datum B and this surface is datum A. It could be attached to a visible surface. For example, just imagine this is like a bracket, and there is a tube here, or a cylinder that is protruded out of this surface, and then the surface of the cylinder itself, this cross section here, is defined as your datum A. It could go in line with a dimension line for this diameter or for this cylinder. But in this case, for example, if this is the diameter of this part of the cylinder, and we attach the datum to this dimension, it means that the center line is the datum. Okay, so when it is attached to a dimension, so you take the center line of this dimension as your datum. Again, here the same, because it is attached to this feature control frame or tolerance frame with this leading line, with this leader line. So it is attached to, which is attached to this dimension. So in this case, the center line here is defined as the datum. So when the symbol here for the datum is lined up with an arrow of a specific dimension, so the center line here becomes your datum. Okay, so I hope this is clear. Datums are used to kind of restrict the surface. So if you look at this, what's called degrees of freedom, in this case, if you have unrestricted free movement in space for a specific part, so this part can move up or down, can move front or backwards, can move to the right or to the left. And for each movement, there is also rotation movement. So here, rotation in the clockwise direction, rotation in the counterclockwise direction. So if you count these, you'll find that you have 6 linear motions, because they consider the right is one motion and the left is another motion. So these are 2 front and backwards, 2 more up and down, 2 more. So we have 6 in total, 6 linear motions, and for each one there is for each movement, for each linear movement, there is an attached rotational movement. So they consider here that we have 12 movements or 12 degrees of freedom. And then when we use datums, we start restricting those degrees of freedom for a specific part. Datums, if we use like datum A, B, and C, primary, secondary, and tertiary datums, they are normally perpendicular to each other. So the primary datum, so for example, if we have this part and then we use the bottom surface as plane A, as the datum A, so we can say that datum B is going to be perpendicular to datum A. So plane A here and plane B are perpendicular to one another. So plane A is used as datum A, plane B is used as secondary datum, and then the third one here, plane C, is used as datum C. So we have primary, which is A, secondary, which is B, tertiary, which is C, and 3 of them are perpendicular to one another. So in plane A, we say that if plane A, for example, is used for inspection, so we place the part similar to what we see on the screen, where we have the reference surface at the bottom here, and then having this datum, we can, for example, measure the location of this part or the parallelism of this surface relative to the datum A and so on. So this is the datum A, and when we use this first datum, primary datum, we restrict 6 degrees of freedom out of those 12. If you look at here the front side top views, you'll find that because we're having this surface here, the bottom surface, as your datum A, so we identify this by this symbol here saying that this is datum A, so that we can later on, using the feature control frame, we can relate to this datum A. Secondary and tertiary datums, this is datum B and C. So sometimes you cannot just refer all the dimensions to the primary datum, so that's why you need to have other datums like secondary datum, for example, which is going to be perpendicular to the primary datum, or tertiary datum, which is going to be perpendicular to both the primary and the secondary datums. So in here, what you see on this view here, we have the primary datum A, we have the secondary datum B, and then they are 90 degrees to one another, and then having this datum as well, meaning that we've started restricting more degrees of freedom of the part. So in here, it restricts 10 degrees of freedom. Just go back to the 12 degrees of freedom shape and see if we restrict the bottom surface here to this plane and the vertical surface to of this surface here, we restrict this back surface here to datum B. So how many degrees of freedom you can restrict? Okay, so you'll find that they are supposed to be 10. In this case, we have the bottom surface as datum A and the vertical surface here as datum B. So you can now start relating some dimensions to or some measurements to datum B as well. Then some other dimensions require more datums in order to measure and locate them. So we'll have to have one more datum C, which is perpendicular to both B and A, as you see here, 90 degrees both. And then this means that this surface here is considered or is taken as datum B. So you can start locating other features using datum C as well. That is the end of session 8. So I'll stop now, and then this is the last session, session 9. That is the upcoming one. We'll see some symbols and examples of GD&T.